Welcome to Safety Division. This is our small display which covers a wide range of radiation protection. Here we are focusing on actual radioactive material that's actually in natural foodstuffs. We have mixed nuts and bananas and fertilizer that people put in their garden, and actually we're demonstrating here with this display that material all around us contains radioactivity. Along here we have some demonstrations of actual radioactive sources. We're teaching children the Greek ABC, alpha, beta, gamma, except that the alpha, beta, gamma is referred to for radiation. And we take common or garden things like the common smoke detector, which is available, sorry, that's the smoke detector. This is a gas mantle, which you can buy in a local hardware store. And that actually has thorium in it, which is radioactive, and we demonstrate with these monitors here, contamination monitors, that it actually has alpha and beta radiation coming from it. We let the kids have a hand-on with it. It's quite safe, it's not a hazard. And we teach the science of alpha, beta, gamma. Use a piece of paper to show that alpha is stopped by paper. Beta passes through it, but it can be stopped by a thin piece of plastic. And
is this the tools you use to demonstrate that?
Yeah, these are contamination monitors here.
Are you able to show us how they work? Or?
Yes, yeah. And this is a smoke detector which you buy in a local store like Kmart, if that's not advertising.
Sure.
But I would advertise them in terms of buying a smoke detector and making sure that people actually install smoke detectors in their homes to protect their families in case of fire. Mm-hmm. But if you actually see the radioactive symbol on it, it does actually contain a small radioactive source, which is an alpha emitter. And it creates a small beam, which when the smoke interferes with the beam causes it to alarm. But the kind of radiation that has in it is the alpha radiation. And this is a contamination monitor here, which actually measures alpha and beta radiation. I've got it on alpha and beta only at the moment, and I don't know if your audio can pick this up. Right, that's alpha and beta. I'm going to switch it to alpha only. And on alpha only, you can't measure it until it gets right up close. Okay, so alphas only travel a very short distance in air, as in the smoke detector sample there. If I put a piece of paper between the source and the detector, it is stopped. If I drop the paper out, you can see still. So alpha particles are easily stopped, and smoke can actually cause them to interfere, right? If I put it onto alpha beta, and I again put the paper there, the beta travels through the paper, right? So it's a bit more penetrating than alpha, but it does travel a short distance in air, but not very far. So if you had a radioactive source near you that was alpha or beta emitting, it'd have to be very close to it to actually measure the radiation or even get impacted by the radiation. The noise level, as you heard there on this gas mantle, wasn't very high, which indicates that it's not a high level of radiation source. And if I put, what do I do with it? The end cap on this detector, the radiation from that gas mantle doesn't come through. But if I get a gamma source, this is a cesium source, a small one for demonstration purposes, you can see that it's coming through the end of the detector. And with that one, we would use lead to cut down the amount of radiation, right? Need a bit more, cuts it down a bit more. All right? So there's three basic principles in radiation safety to protect yourself against a radioactive source. Is time, distance, and shielding. The less time you stand near it, the less your exposure. The further away you are from it, distance, the less your exposure. And if you put some form of shielding between you and the radiation. So some basic principles of time, distance, and shielding we've been teaching to the children that have been coming here.
Great.